everyone. We're going to evaluate the integral of sine squared of x dx using integration by parts. This is the formula for integration by parts. You need a u and a dv. For us, we have this sine squared, and I can rewrite that as the integral of sine of x times sine of x dx. And that way, I'm going to let my u equal sine of x. So that would be the first one. And then dv is going to be sine of x, this part here, dx. Therefore, our du is going to be cosine of x dx, and our v is going to be the antiderivative of sine x dx is negative cosine of x. Also, to make things a little easier, I'm going to call this integral here let me change this up. All right, I'm going to call this I, or I can call this I. All right, it's going to, and then I'll go back to this in a minute. So I'm just going to rename this as I for now. So let's use the formula. I have u times v, so that's going to give you sine of x times negative cosine of x minus the integral of v du. So v is negative cosine of x, and I knew I'd run out of room, and this would be cosine of x dx for du. All right, I'm going to fix this in just a minute. All right, so this is going to equal negative, pull out the negative, sine of x cosine of x minus, well, I have two negatives here, so let's put plus the integral, and this is going to be cosine squared of x. This was a cosine x, and then dx. So I'll just write that a little better. The next thing I'm going to do is for cosine squared of x, I'm going to change this to 1 minus sine squared of x. So using your Pythagorean identity. So negative sine of x cosine of x plus the integral of 1 minus sine squared of x dx. Now, splitting this up, I'm going to take the, integrate the 1, but not the sine squared. So basically, this is going to give me negative sine of x cosine of x. And when you integrate the 1, that's going to be plus x. And then I'm going to put my plus my arbitrary constant, and then minus, I'm going to pull this negative out, integral of sine squared of x dx. Now recall I set this to I, so this whole thing is I, all right, given here. Well, this is also I, so this whole thing here I could write as I. And if it's subtraction, so if I add it to both sides, I'm going to get 2i, right? So then the 2i would equal this, which was negative sine of x cosine of x plus c1. All right, so let's do that. I'm going to do 2 times I and write this out. So it's going to be 2, and my I was sine squared of x dx equals, and then we had negative sine of x cosine of x plus x plus our arbitrary c. Now we want to evaluate this, so just divide each of these by 2 or multiply through by 1/2. Excuse me. This is going to give you the integral of sine squared of x dx equals negative 1/2 sine of x cosine of x plus 1 half x plus 1 half c1. Now we're going to let c1 equal 1 half c1, let it equal unknown constant c. And this right here, I can write this as, I'm going to do this with your trig identities, as negative 1 half times, I want sine of 2x, so I have to multiply this by 1 half, right? So because 1 half sine of 2x would equal, remember sine of 2x is 2 sine of x cosine of x, but I had to multiply this by 1 half to get a 1. And then we still have this 1 half here. So I'm going to simplify that. So our final answer is going to be, our integral here equals negative 1/4 sine of 2x plus 1 half x, and then we're going to use this plus c. And that will be your final answer. Thank you. Have a nice day. Bye-bye.